Good afternoon, everyone. Welcome to session number 3 of our G5 Jumpstart training. This session will be covering product characteristics, calibration of the setup and proper operation of the calibration process, and fan testing. My name is Craig Finstamaker, product specialist for the West Coast and the eastern part of Canada. Joining is Jim Corbin, product specialist that covers the Northeast states and the New England states. Casey Crum, who covers Texas, Oklahoma, Kansas, and New Mexico. And Ryan Sid, who covers the Dakotas, Nebraska, and Colorado. In this session, I'll be covering the calibration process. Jim will be covering fan testing. Casey will cover the product characteristics. And Ryan, he's our pilot of the drone system that shot all the pictures of this presentation. So in the right-hand corner of your lower-hand corner of your screen is a question and answer area. We'd ask that you submit your questions through this presentation. This is a pre-recorded video that we have. It's about a 20 to 30 minute video that we're going to be covering here. So in that period of time, we'd ask you to submit your questions. So at the end of this session, we'll come back and be live again to answer those questions for you. So at this time, we're going to kick on the video and go through this presentation. Thank you.
All right, what we're going to cover here is the SGN kit, which is a separate kit that you buy. It does not come with the spread pattern test kit, and how we were going to take a density. Now there's two ways. We'll start with the density. There are several ways to do it. This is the cup that we provide in the SGN kit. It's a white cup. It's got notches on the bottom of it. As far as filling and doing it properly, there's not a right or a wrong way. It's just be consistent on however you do it. Whether you loose fill it or you fill and tap it, drastically changes the weight of the product. So I personally just loose fill it so that you don't have to worry about how hard you're actually hitting it or hitting it the same amount of times. Just loose fill it till it's full, strike it off, and then you're going to just take a knife and hold it underneath there, and one of those notches till it levels off. On the face of this has a series of numbers. That's going to be your density. The importance of that is when you do your catch test, when you set everything up, everything is driven off of that density. So if you use this cup and you loose fill it, you have to do that in its entirety of that machine. If you change cups, there's a red cup, there's about 4 pounds difference between that red cup and this cup. Or if you tap it or loose fill it, there's 2 to 3 pounds difference there as well. So there's not a right or wrong way, just consistency. The other thing we're going to talk about is the SGN kit. This is a separate kit that you can order. Inside this kit, you're going to get a crush tester and a SGN box with a series of sieves in it, and also a card. What this kit is handy for is to figure out the size of product, your hardness of the product, which is going to dictate your spinner speed. Also, if you're running a blend, you can take this box, shake it out, and if your blend segregates out, that's your limiting factor of that product. If your blend, say you're doing a urea AMS, your AMS is only going to go 70 feet, that's your limiting factor. So easy way to do this box is on the top of it, there is a series of numbers, and you're going to fill the one side that actually says fill. I will caution you, hold the lid when you tip it and shake it, or you're going to dump it all out. Basically, you're just going to shake it out. There's not a set time to shake it, just tell that it quits separating through there. You're going to look at the numbers on the top. In this situation, 80% is in the 280 to 400 range. And in this book, there's a chart that's going to show you these numbers. On that second page there's a chart. There's also a card. Card's a little easier to use. That way you don't have to mess with the book. Plus this is laminated. So you're going to go to the correlating size that matches here. So we're 320 to 400. Now what we're going to do is we're going to take the density, how hard this product is. So this obviously is the same product. So I usually take about 5 test pieces, just put it on the box. And you're going to slide this down until it breaks. And there's a slide indicator right here. So that's at 4. You're going to do this several times to get an average. That's a 3. And you're so on and so forth until you get an average. Usually about 5 is sufficient. So what you're going to do, you're at the 320 to 400. On this card, there's a 1, 3, 6, and 8. So if our average is a 5, I always err on the side of less, on the side of caution. So I will go down to this lower number. And that would be our spinner speed for this. 650 to 700, 85 to 90 feet on a floater, 95 to 100 feet on a post machine. The reason you're gaining that width is you're higher off the ground. Now these are just starting parameters. Basically, that's what I would initially set the machine up to, then do my pattern test to verify my width. And if that was a blend, to make sure that there's no segregation in there, and make sure the product's going all the way out in the entire pattern. So these 2 deals here, this kit here and the density, are very crucial to setting it up and getting a uniform setting throughout all the product and how you're spreading throughout the season.
Casey has went through the product characteristics to identify the differences in products, and we're going to move into the calibration process. Zach had went through the calibration process in the previous controller. One of the calibrations we need to do is the feed gate calibration to confirm that. Once you've determined the optimum gate setting for the rate range that you're working within, once you've selected that, and it displays on the display whatever gate opening that would be, we want to confirm the actual opening of the feed gate. So if you selected, say, the example 3 inches, we want to make sure that the feed gate shows exactly 3 inches. If we do, we want to proceed on to the next step. If not, if the feed gate is not the actual dimensions as what is displayed on the display, we need to go through the actual calibration process. To do that, we're going to go to display. We're going to click on the gear. And under the gear, we want to select gate height. Under the gate height option, depending on the gate we're going to calibrate, whether it's a main hopper, secondary hopper, whichever one it would be. I'm going to check the main hopper, main bin. We're going to click calibrate feed gate. Click on the advanced button, and the feed gate will act, extending all the way down to a lower setting, and we're going to physically measure that. And in this case, this machine dropped to a 1 3/4 inch opening. So we're going to enter that into the display. Once we've entered that, we'll hit the blue advance button, go to the next step, which is going to retract the cylinder all the way, and that retraction will go far beyond what the actual opening is of the end gate itself. When you measure that on this machine, it measured 6.5 inches, fully retracted. So once we enter that, the feed gate will then set. We'll hit the blue advance button again, and the last measurement is going to be what the actual opening is of the end gate. And on this machine, it measures 4.5 inches. So once we enter that, 4.5 inches. Now we have done a complete calibration of the feed gate. So when we hit the green check mark, the feed gate will set itself. And again, we want to measure that to make certain that it is the exact dimension as what we have programmed on the display. Once we've calibrated the feed gate, we want to calibrate for the various products. Whether it's a nitrogen product, a potash, or a lime product, one calibration is not going to work for all products. So we want to calibrate to all those various products. To start a calibration process, once we've got our feed gate set, we're going to load product in the machine. We're going to go to the toolbox and have someone help you that when you press on the button for bin flush, we want to pre-charge the conveyor. On a single hopper or dual hopper, we want to check mark which one we're going to activate, and then we're going to run the conveyor until we have product ready to drop off the conveyor onto the calibration chute. Once we have done that, we're ready to go through the calibration process. Now we're going to dispense product, catch that product, put it back in a measurable scale to confirm our actual dispensable product matches what we had as a desired. We may do that 2, maybe 3 times to confirm our actual output. And once we've done that, that product is calibrated and we can save that calibration number in the product profile. Once we have that completed, we're now going to do a catch test and we'll move into that. All right, we just completed the feed gate calibration, confirming the actual depth of product matches what we actually have programmed into the display. Now we're going to move into setting up for a actual calibration. So I'll go through the physical setup and the adjustment parameters for added safety and ease of operation. So prior to calibration, while we're in the controller, we're going to go into the toolbox, select bin flush, and we're going to manually run the feed gate or run the conveyor so we can pre-charge the conveyor. As you can see, we already have product dispensed off the back of the conveyor. That allows us to start our calibration process. So once we pre-charge the conveyor and have that ready to go, there's a couple things we need to do in the display. First off, we want to go into the toolbox again, go to fan frame assembly, and we want to manually move the fan frame forward, which allows for easy installation of the calibration chute. Once we move the fan frame forward, we need to unplug the 4 aft solenoids on the G5 valve. Then we also want to unplug the PWM valve for added safety, even though the program shuts the spinners off for added safety, so we don't have an accidental engagement of the spinners. We want to unplug the PWM valves. Now we've unplugged the PWM valve and the G5 valve, and we're ready to set up the back of the machine here. And to set up for the calibration, first we want to remove the rear plate of the material divider. Next, we're going to remove the G5 vane assembly. With that removed, we're ready to install the calibration chute. Calibration chute is offered through New Leader as a safety item and to ease the dispensing of product off the back of the machine. Part number 312688 can be ordered through your New Leader dealer. With everything removed, we can install this at the back of the machine. Moving it all the way forward as far as it will go. With the G5 calibration chute installed, we're going to put our safety lock back on. And now we're ready to do our calibration and dispensing product.
Okay, now that we've done our SGN and we have the characteristics of our product and we've done our catch test, we're ready to go out and pan test the machine. Now the difference between the G5 and the G4, like we've done in the past on a G4, if our rates are between say 100 and 400 pounds, we kind of split the difference. So as the product rate would be lower, our pattern would be okay. As our rate would go higher, our pattern would also be okay. But on the G5, we're going to do both of those. So because the fan frame moves forward and back, left and right, we're going to nail this down to where the product actually comes out perfect. So we were going to go out and do our low rate on the product that we're spreading. Our low rate will be 100 pounds and our high rate will be 400. So as the drone video showed on our first test, we did our low rate, which was 100 pounds at a single pass. So here's the tubes. As we see, we're shooting for this flat profile coming across here and tapers at the end. This is going to tell us what our product profile is. All right, as the drone showed on our second pass, we did our high rate, which was 400 pounds. Okay. Here we go. Same thing, we're shooting for this flat profile and where our product comes out. This is showing at the higher rate. Okay, we've done both our high and our low rate. Our next pass that the drone showed was the double pass. So basically what we're doing is looking at what the overlap is. So here's our tubes on that. We can see where the overlap ran across, how it flattens out on that. So on this last drone shot we did, we were doing a remote spread, basically spreading a half swath. The spinner assembly will shift all the way to the one side using just one, spreading just a half swath. Here are our tubes from that. All right, so on this last drone video we showed, we simulated a headland pattern coming back in with our straight pass, showing how the fan frame will shift, not allowing us to double apply in the sections we had already spread. Here's the tubes of that.
All right, everyone. After going through the video, we've had a few questions come in here we'd like to cover. I'll take a couple of the first few questions that came in here. One of them that came in is, when do we pan test? To pan test, we're going to do that at the beginning of every season, or if there's a change in product. We want to pan test to confirm that nothing has changed from the previous year, or if we have done a major repair on a machine for whatever reason. Changing spinner motors, changing hydraulic components, whatever. We want to pan test again just to confirm that everything is still operational and we're getting the same results as we had done previously. Another question that came in was, what products do we pan test and why? We're not just going to go out and pan test one product. Say, for example, potash. We're going to pan test various products, and the reason being for the product characteristics. If you take a nitrogen product that is a round granule or ammonium sulfate, anything that's a round characteristic, that product has a tendency to roll in the conveyor belt as you're dispensing product through the feed gate. That has a little more slippage of product in the conveyor belt. But if you take a potash, MAP, that type of product is more of an angular shaped product. That product has a characteristic, more of a sliding characteristic. And so those two different characteristics, as well as line, because of different densities, those products are going to flow different. So we can't just do one calibration and expect to use that calibration number for all products. So calibrating those three different product characteristics is going to give us a good starting point to make certain that our products coming out correctly. Why do we pattern test? Our spread pattern design is throwing a flat top pattern. And as product goes out, we're looking at the overlap area to confirm that our overlap is consistent and uniform as it is across the back or across the whole area of the spread pattern profile. We're wanting a symmetrical pattern across the whole back of the machine. There's some other questions come in. I'm going to pass it over to Ryan and I'll let Ryan share a couple of other questions here.
Thank you, Greg. Okay, what I'm going to cover here is we've got a couple of questions on the video that showed our double pass and why do we do that, and is that how you're supposed to do your multi-pass test? So in the video we showed you a double pass, and the reason why we showed a double pass is because we didn't have the room at the facility we're at here to actually do a full triple pass. Why do we want to do a triple pass? What's the importance behind that? The reason why we want to do more than just one pass down the center of the pans is so that we can check the overlap as you would be spreading it in the field. And how you do that is you saw Craig in the video, he drove down the center of the pans and then he made his turn on the end and came down the far side. How you would do that in a field application or when we're actually field testing is we would start on the far side, drive through the pans, come down through the center, and then go down the far side. And that way, when you pick up the vials, you're actually seeing the full pattern that's going to be applied in the field. Both overlaps from both sides of the machine. Next, I'm going to hand it over to Casey here, and he's going to go over some questions we got on pattern troubleshooting.
Thank you. All right, one thing I want to reiterate, I didn't mention in the video, is when you check the density, again, it doesn't matter how you do it, as long as you're consistent, but you need to do it on every load. There is a lot of variation between where that is in the pile, as far as if it's on the outside of the pile, the middle of the pile, that kind of stuff does play a role in that. So try to get in the habit of checking your density every load, make whatever changes in the display that need to be done. A couple of the other questions are adjusting spinner speed for your whip and going to moving the fan frame closer and further away from the conveyor and what that does. So basically on that card that I showed you on the in that kit, on the back of that card has illustrations representing what a pattern would look like. Now obviously we didn't show that in the drone videos, but if there would have been a situation where we were high behind the machine, you would move that fan frame closer to the conveyor. So basically in the tubes, use that as an arrow. So if it goes spikes in the middle, you're actually going to move the conveyor closer or move the spinners closer to the conveyor. On the side of that machine, down on the bottom left-hand side, there is an actual rule indicator. A lot of times that gets covered in dirt, dust, and you can't really generally see it. But a spike in the center, you're going to go closer to the conveyor. If you got a dip or it's low in the center, you're going to come back. As far as spinner speed, that's going to just give you your overall width. So by moving the spinners forward and aft, that's going to give you your flat top profile. So that's where that all kind of works together. So I'm going to hand this off to Jim. He's going to cover a couple other questions here.
Thank you. I had a couple questions, I ran a couple questions come in online, and can the G5 do line? The answer is yes. That vane assembly you saw Craig remove when we did our catch test, that would have to be removed first, because we're not going to section line. We're doing a mass, and we cannot divide that up into our 16 sections. So line can be spread from a G5. We'll take the vane assembly out, and we'll spread it just like we did in our G4. It can be done. The one thing I will say after a lot of the line that I've tested, pan tested, is the tubes are kind of small. So a lot of guys are testing like 3-ton of line. So I've actually gone out and got some larger clear plastic cups, and we've dumped the pans into those, numbering the cups, and ran across, and that's how we tell how even our line pattern is. Okay. Craig, you got a couple more questions here?
Yes, Jim. Thank you. A couple more questions that just came in here at the tail end, and the question was, how big are the pans and are they available at the dealership? Yes, you can order the pans through your dealer as part of the pan test kit or individual as well. The pans are a 15 by 18 size pan, typical size dimension wise to meet the standards for application and testing. And the last question that came in that we have here is, what's the difference between the collar or the collars of the density cup? The density cup that comes on the new leader pan test kit is a white density cup. That's used, as Casey showed in the video, fill your density cup up using a knife to determine the density of that cup. There is a red cup out there that has a sliding weight that allows you to use a bubble to balance out that scale to determine your density. Those scales work great. Whichever one you want to use, as Casey shared earlier, to be consistent. But if you're putting a white density cup at the blender and you're using a red density cup at the unit itself, that's a no-no. There can be as much as 4 pounds difference between those two cups. If you fill the cup up loose versus packing the cup, it can be as much as 3 to 4 pounds difference on a white cup, but it can be as much as 4 to 5 pounds or 6 pounds difference on a red cup. So however you're calibrating the machine, if it's a white cup, that's being used for all your density checks. If it's a red cup, you're going to use the red cup for all your density checks as well. So hopefully that answers all the questions that we received in. We appreciate your time and your dedication to take the time to learn from what we have to share. If you have questions, please call your dealer. They can contact us, and we'd be more than happy to support you or visit with you to answer or support you in your efforts. We want to make sure your machines are working properly. And again, we appreciate your time. And from here, have a great day and appreciate it again. Thank you.